then it is going to be y is equals to a plus b sine theta minus b sine, take the theta common. Here is going to be 1 plus a divided by b, 2. And there we go. We found our y coordinates of P. So using these two, and we can use this to find out the epicycloid orbit of the Earth, and I just show you the mathematics. Assalamu alaikum, dear viewers. Today I will show you the epicycloid orbit of the Earth using mathematics. And with those mathematics, we need the parametric equations. And you know, my mom has bought me a cool set of spirograph. I'm pretty sure all of you know what spirograph is. Spirograph is a cool set that lets you do designs. It has rings and wheels. This is the rings. These are the rings. And these are the wheels. There's many more wheels there. And these are the cool, and they also let you do cool designs here. See? These cool designs. See? That you do really cool designs here. And you know, while doing them, I thought, are they just doing designs, or is there any mathematics behind it? And then I found out, oh yeah, there is. So here, as you can see, this is a hypocycloid design, and it's actually the ring divided by the wheel. Ring divided by the wheel. The ring number 96 divided by the wheel number 42. Highest common factor, I had to take them, which is 6. And then the numerator that came out is the number of petals there are in this design. Just like that. The hypotrichoid, there's 42 petals. These ones are actually inside the rings. The designs are inside the rings. But this one is pretty different because I took the wheels and I made the designs outside the rings, which made it a little different. And you know, when it's related to real life, when astronauts go to the moon, they go in this way, but they don't come back to the Earth in the same way because they know that the moon has changed its position while orbiting around the Earth. So that's why they go on a different route. And this is how the Apollo 11 went to the moon and came back to Earth. And here, as you can see, the Earth is going in its epicycloid path, but it's not going in a round orbit. It's going in an epicycloid orbit. As you can see, it's going an oval one. And also, engineers also need these types of parametric equations and spirograph in math because for example, when they build an arc bridge, how will they know in measurements where to create the arc? Because you know, you need math to find out how you can put the designs up to find the arc, right? And so I'm going to show you the parametric equation now. Here, as you can see, my dot is right here. This is the bigger circle, but I didn't draw the whole one. I just draw the part of the bigger circle, and this is my smaller circle. This is the dot. See, when this is rotating around the edge, when the small circle is rotating around the edge of the bigger circle, it is going like this, right? And actually, this point started off right here, and when the small circle went turning around the edge of the bigger circle, this dot actually went here. And this is the trajectory of the smaller dot. And see, when it starts here and comes right here, this is how it goes when the small circle is right here, right? So now I will show you the mathematics here. So first, let me glue this on here. Let me glue this on too. Okay, here. So remember, my center has to be here, okay? And if I name this my P point, okay? If I name that my P point, okay? And then, so here is my one radius, my radius of the big circle and the radius of the small circle. Radius of the big circle, I'm going to name it A, and radius of the smaller circle, I'm going to name it B. Actually, the radius of the smaller circle is half of the radius of the bigger circle. So this is bigger and this is actually half. Okay, and well, the total radius of both of these is actually addition, right? To figure out the total radius, and I'm going to name that R prime. So now I will need that while doing my math. So I'm going to write here A plus B is equals to my R prime, right? I'm going to need that. And here, as you can see, there is two arcs. And these two arcs are actually equal. That's why I put them in the same color. How do I know they're equal? I can prove it to you. See, this is how long the arc of the bigger circle is, and this is also the same. This is how long the arc of the small circle is. As you can see, they are the same. They're the same height, so that means they have the same arc, the same height of arc. Okay, so that means that it is actually S is equal to S. What do I mean by that? I mean that actually this arc is equal to this arc. This is when I can write that. Okay, and then to figure out this arc, the arc of the bigger circle, it actually has to be, I'm gonna name this theta. This angle, I'm gonna name it theta. Okay, if I do name that theta, then it is A theta, because to figure out arcs, I need to do radius times the angle that the arc creates. So it's actually A times theta, which is actually A theta. So A theta is equals to the arc on the smaller circle. It is actually B times this angle that the arc creates. I'm going to name it phi. I'm going to name it phi. If I do name that phi, then it is going to be B phi. B phi. Okay? If it's B phi, then if I want to figure out phi, then it actually has to be phi is equals to A divided by B theta. So I figured out phi right here. Okay? And here I figure out phi. So if I'm going to name the center right here of the smaller circle O. If I do name it O, here, let me write it so that you guys can see. If I do name it O, then I want to figure out the x. This is my x-axis, this is my y-axis. I want to figure out the coordinates of O, right? So if I want to figure out the coordinates of O, then this is going to be my y prime, but my y coordinate for O. Okay, let me glue that on to there. So this orange line is actually going to be my y coordinate for my O, or the center of the circle. Okay, and I'm going to name it what? I'm actually going to name it here. I'm going to name it y prime. Okay, so if I write it y prime like that, then what about this part? Because this is also coordinate. This is the this is the x coordinate of O, right? And I actually want to name it x prime. Okay, I actually want to name it x prime, and for that, here is going to be my x primes. One second. But as you can see, this is going to be my x coordinate. My x coordinate, remember. My x coordinate for O. Here. here, my x coordinate for O, okay? And then I'm going to name this x prime. Let me write it down here, x prime, okay? So if I do name it, one second. If I do name it x prime, then if I want to figure out x prime first, then as you can see, here is a right angle triangle. How do I know it's a right angle? Because see, this is a right angle, right? And if I name this theta, right? So then I have to work with this hypotenuse and my base. My base is actually x prime. Remember, this is my x prime. And my hypotenuse is r prime, right? So it's actually base divided by hypotenuse. So if it is, then it is base. Then it is base. Oh, sorry. Base is x prime. X prime divided by my hypotenuse, my r prime, is equals to my angle's name. It is actually theta. So if my angle's name is theta, then I'm going to write theta right here. And then usually in the trigonometric equations, when it's in the case of a base divided by hypotenuse, they write a cos. Okay, so it's cos theta. Now, but I want to figure out x prime, right? So then I'm going to write x prime is equals to r prime cos theta. Why? Because this r prime, when I multiply it here, r prime is going to go up there. It's going to be multiplied there too because I multiplied it here. So it's going to be r prime cos theta. But wait, I already figured out r prime. R prime is actually a plus b. So x prime is equals to a plus b cos theta. Okay? This is my x prime. I figured out one coordinate for my O, and that coordinate is my x prime. Okay? And same way, I want to figure out the y prime. To figure out the y prime, I'm going to do it the same way, right? So
you have to think about another triangle.
Yeah, I have to think about my triangle. Here is my other triangle. Since this orange line and this yellow line are parallel, and this blue line is intersecting them, then that means that this part, this angle and this angle are equal.
Show that with a mark with the angle.
Yes. Here. They have to be the same color because since they are equal, right?
Because they are alternate angles.
Alternate angles, yes. They are alternate angles. Here. I'm going to glue it on there.
So what will you name that? Same name?
But yeah, I'm going to name that same name because they're equal, right? If they're equal, then I have to name them the same name. I am going to name that theta 2. I'm going to name that theta 2. Okay? Now I want to figure out this theta. Then I have to do, here is my length. I have to work with my length and my hypotenuse. Usually in the trigonometric equations, it's a length divided by hypotenuse. If it's length divided by hypotenuse, then it has to be y prime divided by r prime, right? So if I write that down, y prime divided by r prime is equals to, remember, my angle is theta, right? And in the trigonometric equations, when it's length divided by hypotenuse, then it is sine theta, okay? And I want to figure out y prime, so just like that, I have to do y prime is equals to r prime sine theta. I already figured out r prime. R prime is a plus b. So y prime is equals to a plus b sine theta. I figured out the two coordinates of O. But I didn't want the coordinates of O. I wanted the coordinates of this P, of this angle, of this dot, sorry. So then if I want to figure out those coordinates, then it actually has to be like this, right? So that is going to be my y coordinate. And actually, I'm going to name this I'm going to name this y, not y prime, y. Okay, and it has to be like, just like that. Okay, just like that. This is my y here. I'm gonna write y here. Okay, but there's this coordinate left. That is going to be my x coordinate, and I'm also going to name it x, not x prime. Just like that. Okay? Here. I should do it like that. Okay? That is going to be what? That is going to be my x. Okay? If that is my x, there's another right angle triangle. As you can see, this is a right angle triangle because there's a right angle right here. And I'm going to name this part n. I'm going to name the length n and the base m. So if this is n, then that means this part is also n, right? And yeah, and then I have to work with this angle. And oh, this is also b because these two are the radiuses of this smaller circle. And we know that whenever a radius comes from the center of the same circle, then all of the radiuses are equal. So that means that if this is b, then this must be b too, right? So I'm going to name that b. And here is the angle that we have to think about. If that is the angle that we have to think about, I am actually going to name that beta. Okay? I'm going to name that beta. Yeah, this angle is also equal to these two angles, which is actually these two angles. Here, let me show you. Right here, like that. Okay? Here. Yeah. Oh, sorry. Like that. Okay? So this is equal to that. You know why? Because the orange line and the red line are two parallel lines, but this blue line, not this one, but this blue line is intersecting them, which means that this angle must also be equal to that angle. There are two alternate angles and they must be equal, right? So, and then if they are equal, then this angle is actually theta plus phi is equals to, I'm going to name this, remember, beta, okay? So, theta plus phi is equals to beta. Okay, because they are equal, right? So this is beta, then the total must be beta too, which means these two addition. Right? So if that is, then I want to figure out m. To figure out m, the equation must be if I want to figure out, here is my base and this is my hypotenuse. So base divided by hypotenuse, which is actually m divided by, that is b, right? So m divided by b is equals to my beta, because that is the angle. My beta. And in the trigonometric equations, if it is base divided by hypotenuse, then it's a cos. Okay, so m divided by b is equals to cos beta. But I want to figure out m. Okay, so if I figure out m, that is equals to b cos beta. Why? Because when I multiply it here, I also have to multiply it there. So then it's b cos beta m, right? So then to figure out the x, yeah, I know beta is theta plus phi. So m is actually, simplify it, so it's b cos, here is theta plus phi. Okay, so I guess this can be the value of m. But here, to figure out x, I want to figure out x, one of the coordinates of p.
Right.
Then the total is x prime here, right? If the total is the total is x prime minus the m, right? Minus the m, because it's this part, minus the m, is actually my x, okay? And remember, I already figured out my m. So then it's x prime minus because theta plus phi. Theta plus phi. Okay, so this, oh yeah, I also know my value of x prime. X is equals to, my x prime is a plus b cos theta, right? So a plus b cos theta minus b cos, but remember, here is theta plus, I already know my phi. My phi is a divided by b theta. So a divided by b theta, right? Here I can take theta common. So basically my next line would be x is equals to a plus b cos theta minus b cos. Remember, I can take the theta common. Then this side, here would be 1 plus a divided by b. Congratulations, we already figured out one coordinate of P, which is the x coordinate. The x coordinate is a plus b cos theta minus b cos theta, 1 and parenthesis 1 plus a divided by b. Okay, so the same way, like that, I have to figure out my y coordinate for P. To figure out the y coordinate, we can say that y is equals to my total, which is y prime minus n. It's going to figure out that part, right? So minus n. And I have to still work with the same angle. If I have to work with the same angle, then I also have to work with a beta. So then that is n divided by my length divided by my hypotenuse. And it's n divided by b, right? So n divided by b is equals to my angle beta, right? And in the trigonometric equations, when it's length divided by hypotenuse, then it's actually sine beta, okay? But I want to figure out n. Then n is equals to a b sine beta. I already know my beta. My beta is actually theta plus phi is equals to beta, right? So n is equals to b sine theta plus phi. Yay! Okay, so now we figured out the n. But here, remember, we have to place the value of n here. So then y is equals to y prime. We already know that. Y prime minus a b sine theta plus phi. And then y is equals to, remember, y prime is a plus b sine theta. A plus b sine theta minus b sine theta plus, we already know our phi. Remember, our phi is a divided by b, and then theta is equals to phi, right? So a divided by b theta. Okay? And just like that, we can take our theta common. If we want to take our theta common, then it is going to be y is equals to a plus b sine theta minus b sine, take the theta common. Here is going to be 1 plus a divided by b, 2. And there we go. We found our y coordinates of P. So using these two, my x coordinate and my y coordinate, we have just found out the coordinates of P. And we can use this to find out the epicycloid orbit of the Earth. And I just show you the mathematics. So, and this, using some parametric equations like that, the NASA, the people who boarded on the Apollo 11, they went to the moon and came to the lunar landing trajectory. So now I have shown you the math, and I hope you liked it. Assalamu alaikum.